Hello, hello, hello. In this brief worked example, I'm going to show you how to locate the center of mass of two different collections of masses. So we'll start off with this collection of 4-point masses located on the corners of a rectangle with the rectangle has a height b and a width a. And so let's find the center of mass. We recall that we defined the location of the center of mass as a kind of weighted average of the position vectors of the masses in the system. What's the big idea? We did this for a system consisting of only 2-point masses, but it's pretty clear we could extend that argument to refer to any number of point masses that make up our system. And so here we have 4-point masses, and the definition is this sort of weighted sum of the positions of the 4-point masses divided by the sum of their masses. Whoops, that's a 3, and that's a 4. And the numbering scheme, we've just arbitrarily decided to number these masses. This is mass number 1, mass number 2, mass number 3, and mass number 4. So now I'm just going to go through and I'm going to write down. So mass number 1 has a mass of just m, and its position here is 0, 0 on our coordinate system. Mass number 2 has a mass of 2m, and its position, it has a x-coordinate of a and a y-coordinate of 0. Mass number 3 is also 2m. Its coordinates are a, comma, b. And finally, mass number 4 has a mass of m, and its coordinates are 0, comma, b. And now I've got to divide by the sum of all the masses, and it's easy to see that the masses add up to 6m. And we see that the m's are going to cancel. The m in the denominator cancels each factor. Each term in the numerator has a factor of m, and they all go away. And what are we left with? Well, the first term, 0, 0, goes away, of course, and then the 3 terms just multiplying out here. This is what we have, and it's all divided by 6. So then when we just add up the terms in the numerator, and we get 4a, comma, 3b divided by 6, and so that works out to be 2a over 3, comma, b over 2. Okay, and does that make sense as the location of the center of mass of this object? What is it telling us? It's telling us that the x-coordinate is located 2/3 of the way along here, and that's not surprising because we have these 2m masses here and only m here, so that shifts the center of mass 2/3 along the way of this rectangle in the x direction, but in the y direction, the thing is symmetric. There's just, the point b over 2 in the middle, there's just as much mass above it as below it. So if we're going to locate the center of mass on our little chart here, our center of mass is somewhere right around there. So that is one example. Let's do one more quick example. So what if we're not dealing with point masses, but more continuous objects? So I've got this pattern, L-shaped pattern of floor tiles here, and it's sort of 3 and 1. And we'd like to know where the center of mass of this L-shaped collection of tiles is. And well, that's pretty simple because really we can replace each floor tile has a center of mass located right in its center. So I'm going to put little purple dots right at the center of mass of each of the 4 floor tiles. And now I want to calculate, the problem is equivalent to finding the center of mass of a collection of 4 identical masses that are located on this on the locations indicated by the purple dots. So where would that center of mass be? Well, we're going to follow, let's just follow our formula. Let's number these dots. We'll call this dot number 1, dot number 2, dot number 3, and dot number 4. And the formula for the center of mass of this collection is M1 R1 plus M2 R2 plus M3 R3 plus M4 R4 divided by M1 plus M2 plus M3 plus M4. And because these floor tiles are all identical, all of the M's are the same. And what you can see is going to happen, the denominator is going to be 4M, and then there's going to be a factor of M in each of the terms in the numerator. So what we're going to get is the location of the center of mass is equal to 1/4 times R1 plus R2 plus R3 plus R4, like so. And that's just equal to 1/4. And if the tiles have a width A, we can see that I've just marked off the X and Y coordinates of the various dots on the figure there. So this is 1/4 times R1 is located, mass number 1 has a 0, 0. Mass number 2 is 0, A. Mass number 3 is 0, 2A. And mass number 4 is A, 0. So if we add all these together, we get 1/4 times A, 3A, or A over 4, 3/4 A. So the center of mass of these objects is located, I'm going to pick a different color here. It's in the X coordinate, it's 1/4 of the way along, so it's somewhere around here. And in the Y coordinate, it's 3/4 A, so it's somewhere right around there. So the R sub CM is somewhere right around there. And that looks pretty reasonable for this collection of point masses. So that's it for this worked example. Hope to see you again soon. Bye bye.